Okay, Josh, I'm going to see how this works. You're my first trial. So I like what you're doing on factoring on problems like 15. You got the right idea. You've just factored the thing, and you factored this correctly. P plus 8, P minus 8. It's the difference of two perfect squares. P squared is a perfect square, and 64 is a perfect square. So those are done well. So the other problems here are kind of interesting because here's what I'm looking at. Let's see if I can make this work. You're just going to have to be patient with me. So the thing you should notice on problem 16 and the rest of them is it's inherently different. They all have equal signs to them, which means that when you have an equal sign, you're trying to find out the values for x that make the equation true. All of a sudden it became an equal. And so we did this little process that is called the zero product rule that's kind of important. And so here's, let me see if I can get this. Whiteboard, save and clear, boom. Sorry, I want to get rid of this pen and I want to go to my effects. Maybe that's what I want. So there we go. So what I'm going to do is I'm going to look at number 16. I'm going to look at something like 16, but I'm not going to really do 16. Let's say that I had two numbers, A times B is equal to 0. Well, if that's true, then you're going to tell me either A equals 0 or B has to equal 0. Okay? That's just kind of logic. So I have two things. Now, this is very similar to that problem. If I have A minus 7 times, if I have x minus 7 times 4x plus 2 equals 0, notice that I have two things multiplied together that equal 0. Well, if that's the case, then one of them has to equal 0. So I'm going to take a moment, and I'm going to take x minus 7, and I'm going to set it equal to 0, and I'm going to solve. So x is equal to 7. If x equals 7, then this expression equals 0. But then I also have to solve for the second one. 4x plus 2 equals 0. So I'm going to solve, and I get x is equal to negative 1/2. If x is equal to 7 or negative 1/2, then this expression is going to equal 0. Now what's really important is this, is that you're going to look at 17, 18, 19, and 20, and they're all exactly the same. You factored them correctly, and on 17, you want to take a moment and you actually want to say, you want to set these things equal to 0. You don't want to just say, oh, negative 1 or 6, because negative 1 isn't a solution for this, and 6 isn't a solution to this. You need to think about what x minus 1, you need to say x minus 1 equals 0. When does that happen? And you're going to solve, and you're going to show it, because that's the way you want to do it. The same thing with number 18. You're going to factor this thing, and then you're going to set the factors equal to 0. And number 19, you're going to factor this thing. You're going to factor it and then set the factors equal to 0 to find out the values for x that make the equation true. Now the other thing that I guess I would say is to check on problem, maybe it's, number 17. Take a look at number 17. If you multiply x minus 1 times x plus 6 do you get the original expression back? Well, I multiply the x's together, I get x squared. I multiply x times 6, I get plus 6x. I multiply negative 1 times x, I get minus x minus 6. This gives me x squared plus 5x minus 6, not plus 6, which is what was given in the equation. So I don't think you have that quite factored right. So you want to correct the ones that I pointed out, okay? Hopefully that helps.